real quick, too, I just wanted to show you some notation before we move on. If you have that has an inverse, so maybe something like say we got natural log x plus 2. I wanted to get to a different kind here, too, so you weren't just seeing the same types every time. So natural log of x plus 2. This function is 1-to-1. Okay, I'll just let you know. It will pass on a line test. If you think in your head to what the basic function natural log x looks like, if you've got those graphs in your head yet, I don't know. But if you do, if you can visualize it, it is definitely 1-to-1, right? Okay, it passes the horizontal line test. So the inverse of this real quick. Y equals natural log x. So I do my inverse steps. Now it's x equals the natural log of y. I'm just going to just solve this thing out the rest of the way. So x minus 2 equals the natural log of y. So y equals, to undo this, I'd have to e both sides. Okay, so a little review there real quick about changing logs to exponentials and vice versa. We'll do more of that later, but that's how you would switch that one up. So now it's an inverse. It's not it's an inverse. It's an inverse. To show it's an inverse, you have a special connotation for that. So you do f to the negative first power. You're not actually raising it to the negative first power. Just notation for it. Okay, so if the original function is natural log x plus 2, then the inverse of f of x is e to the x minus 2. Okay, that would show this down here is the inverse function of this function up here. Okay, using that notation. That's how you would identify that. Okay, just wanted to show. Stuff relate to the parametrics that we were talking about yesterday. Okay. Well, inverses talk about taking x and y and switching their roles. Okay. Equations, we had two equations. So if I had a pair of parametric equations and I wanted to find an inverse, could not be easier. Okay. If I can find my pencil, I can show you that. Oh, here we go. So, real quick, let's talk parametric inverses. So let's say I've got a t equals t squared plus 1 or something. I of t equals maybe the square root of t plus 4. And let's say I don't know what's the inverse of that pair of parametric equations. And you might go, oh, crap, I got to do all that inverse stuff they just talked about. And some will apply to stuff with t. This is going to be confusing. It's not. Think about what you do when you take an inverse. You swap x and y, right? Okay. So if this is the original set of parametric equations, the inverse, what do you suppose x of t is? Yeah. It becomes y was equal to square root of t plus 4. And what do you suppose y of t is? T squared plus 1. It's super easy. Done. Okay. And I'm going to jump on your calculators here too so we can kind of take a look at this. Okay, your calculator can plot parametrically. I'll show you how to do that. And then because of that, we'll be able to take a look at a graph of equations and its inverse at the same time. Okay? So, what I'd like you to do first here is go into mode. Fourth row down is your kind of graphing mode that you have. There's which is what you're used to. It's always the y equals and you type something in. But there's 3 others, and we're going to explore 2 of the other 3 at some point during the year here. Parametric is the par. Pole is polar, which we'll do in the B section of this class. And this one we won't get to, but in calculus we do it a little bit. It's called sequential mode. That's if you're doing like C, you'll learn about later. So anyway, so if you come down here, let's switch it to par. Okay, and then just exit out of that. And now go to y equals. Notice how it's changed. Instead of just y equals something, you have x of t and y of t. You got to put 2 equations in. Okay, so what I just did in class. All right, just see what it looks like. So we had t squared plus 1. Got that t by the variable button still. I want to show you something here. I'm going to zoom way in on this. Take a look at this button. If you've ever been confused about this button before, don't be anymore. Has everybody been using this for x whenever you type stuff in? Okay. Take a look. It's x, t, theta, n. What do you suppose each one of those are? They're variables for the different modes. This is function. This is parametric. This is polar. This is sequential. So every time we press this button, now that we're in, I'm going to do a t instead of an x. Okay, it just automatically does that. So it's kind of a neat little thing there. Anyway, so we're in here now. So let's get the other part. It was what? Square root of t plus. Okay. Before you go look at the graph, we got to set up the window too. And the window's a little different. Okay. Notice it says t min, t max, t step. Well, when we were playing in parametric mode, we had to have a point and a stopping point, right? For the path we were traveling. Okay, so we got to tell it what's the t value you want to start with, usually 0, and then where do you want to stop it. So to something that should be sufficient. Yeah. Yeah. Okay. Step. Okay. The thing is going to play a game of connected when it makes this. It's going to plot the points along this curve and then connect all of them together. Okay. So the t-step tells the calculator to recalculate a new point. Okay. Does it want to? Should you like just have it do t equals 0, 1, 2, 3, 4, and 5, and then connect those together, or right at it at point 1? So it's going to do. It's going to plug in a 0, it's going to plug in a 0.1, 0.2, 0.3, 0.4, 0.5, all the way up to 5. And then take all those points and connect them together. So the smaller your t-step, the more smooth a curve you're going to have when you're done. It's going to look more accurate the smaller that number is. Now, caution, if you make this number too small, your calculator is going to sit here and kind of choke on it. Okay? It'll take a really long time for it to graph. Okay? 0.1 I have found, in general, tends to be a kind of a happy medium, or 0.01 isn't terrible either. But if you make it like just 1, it's going to look real jagged and not look real accurate. But you want somewhere in the middle where you're not going to have to wait a half to plot it, but at the same time, it actually looks pretty good when you're done. So we're going to go with that. And this one, we're going to have to some 25 for the y mins and the y maxes, so let's switch those up. Okay. We can keep the scale at 1. Okay, so switch those up too. We want to be able to see the whole thing. And once that, now the graph. Okay. Okay, so there it is. It's this really flat, skinny thing that comes out. So if I inverse at the same time, super simple. Go down to the side here. Swap them. Okay, so square root of t plus 4 for the x, and t squared plus 1 for the y. And so when I graph this thing, it should look like the reflection of the other one we just did, right? So let's take a look. And lo and behold, it is. Okay, and that works for any set of parametric equations. If you're looking for an inverse, you can do that on the calculator and look and see what the graphs look like. Yeah?
Mine's just not graphing.
Window range. Oh, it's because your y max is negative 25. That should work now. Yep. Play around with this a little bit, experiment with some other ones that are maybe a little more interesting looking. That's fine. I think that would be good. But to kind of show you how you can do that. To work here on your homework then.